Welcome to Math 0965, 6.5, a general factoring strategy. In this section, this is a review of sections 6.1 through 6.4, putting them all together and giving you instructions to factor completely. So you were given a flow chart to look at last week, and I would encourage you to look at that as you're going through these problems. We're starting each problem the same way, asking if there's a GCF. If there is, we take that out, and then we ask ourselves, how many terms are in the parentheses? Are there two? Then we'll look for difference of two squares, the sum or difference of two cubes. If there are three, we can ask if it's a perfect square trinomial, or if we can factor the easy way or by AC method. If there are four or more, we'll try factoring by grouping. So let's check it out. As we're looking at these problems, right, we notice that in letter A, you see an x cubed. You may be tempted right away to think, oh, this is a difference of perfect cubes. But when then I look at the 5 and the 20, I recognize those are not perfect cubes. So we need to back up and ask ourselves if there's a GCF. And in this problem, there is a GCF. It's 5x. When we pull the 5x out, we are left with x squared minus 4. In the parentheses, you have a difference of perfect squares. And so we'll continue with the next line, bring down that GCF, and the difference of perfect squares would leave us with x plus 2, x minus 2. And that is our final answer. Letter B, again, start each problem the same way. Is there a GCF? And in this problem there is. They have a 7 in common and an x in common. When we pull that out, we're left with x squared plus 1. Right? And so when you're checking inside the parenthesis, you're asking yourself, what can I do with two terms? And in this case, because I have a perfect square, right, I'd also have to have a subtraction sign, difference of perfect squares. We do not have a difference of perfect squares here. We have the sum of two squares, which cannot be further factored. And so for this problem, we are done. Alrighty, letter C is looking similar. Again, is there a GCF? We are going to assume that we are always going to look for something in common. In this one, we will pull out a 2x squared, and we're left with x cubed plus 1. We'll further check inside the parentheses. In the parentheses, we have a perfect cube and the sum of another perfect cube. So yes, I can further factor here. So I will use the formula a cubed plus b cubed, right? Which is a plus b, remember start with the same sign, times a squared minus ab plus b squared. So this will be one of the two formulas you should memorize for your exam coming up. Alrighty, so let's see, in this one, I know that 1 in front, right? So 1x or x is my a. And my b is also 1 because 1 cubed is 1. So let's go right to the answer. Bring down your GCF, 2x squared, right? This is a, this is b. So a plus b would be 1x or just x plus 1, parentheses, a squared, x squared, change sign, minus x times 1, which is just x, plus 1 squared, which is also 1. Here is your final answer. So notice A, B, and C all started the same. We took out a GCF. Sometimes in the parentheses, you can go further like we did on A and C. And sometimes you are just taking out that GCF. Okay, next problems. Letter D, it's a trinomial. It looks like it's in descending order. So I will take the GCF out. I want to remember to take out the negative sign. And it looks like they're all even, so we'll pull that 2 out. Remember, every time you take out a negative sign, your signs are going to change in the parentheses. So we are left with x squared, change your sign, minus x, change your sign, minus 56. We will look in the parentheses. It is a trinomial. The leading term is 1, so we can do this the easy way, which means we can get right to the answer without doing AC method, right? So I'm looking for factors of 56 that subtract to give me 1, right? So if I use 8 and 7, right, I'll go to my parentheses, x times x, 8 and 7, right? I need to end up at a -1. I know my signs are different. It should be -8 plus 7 to give me -1. Right? And that is your final answer. Letter E, factors of 16, right? That do what? Subtract to give us 8. So factors of 16. 16 times 1, that's 15. 8 times 2, when I subtract, that's 6. 4 times 4, when I subtract, that is 0. Right? There are no factors that would satisfy this trinomial. Right? Our final answer here should be prime, which means it's unfactorable. Letter F. Is there a GCF? Yes, there is, and it's x, right? They have that in common. X squared minus 25, right? Always asking ourselves, can I continue? Perfect square minus, that's key, a perfect square. Yes, I can continue. Bring down the GCF, x, and now I have x plus 5 times x minus 5 to give me my final answer.